Hello everyone. So in this video we are going to learn about chemical reactions and how these chemical reactions occur and what is chemical reactions. First thing that come up in our mind is what is this chemical reaction? Okay, so we will learn this by a example of water. So how water is formed. So for this we can take hydrogen and we can take oxygen, and when you add these two you will get water under certain conditions. Okay, so by this what we learn is that a chemical reaction is a chemical change in which one or more substances are destroyed to create new substance. So here H2 and O2 are combined together and they are making H2O liquid, which is also called as water. Next thing is parts of a chemical reaction. So whenever we see a chemical reaction, we see two parts. One is reactant and one is product. And these two parts are separated by a arrow. So on the left side of arrow is the reactants, on the right side of arrow is the product. So in last example of water, you may have seen H2 plus O2 and then it is making H2O. So this reaction is not balanced. So here this H2 and O2, these are the reactants and this H2O is product. So we can also define reactants as substances that are destroyed by the chemical change. So what is happening here? Here the bond is breaking. So in hydrogen and oxygen, bonds are break between hydrogen and oxygen, and a new bond is formed between hydrogen and oxygen, that is in the product. So in product, substances are created by chemical change, and that chemical change is nothing but the bond formation. And these two are separated by a arrow, and this arrow is read as yield. So next thing is symbols that we use in chemical reactions. Okay, so these symbols that you see here, liquid, solid, and gases, these are based on the state of matters. So the reactants may be solid, reactants can be liquid, reactants can be gases, or reactants can be an aqueous solution. That is when solute is dissolved in H2O. So based on this states, we can symbol them as S for solid, L for liquid, G for gases, and AQ for aqueous solutions. Okay, and when you are putting one more than one reactant, then you have to separate them with a sign of plus. Okay, and then at last the product and reactants are separated by a arrow, and this sign is also called as yield. Now we have a few examples of chemical reaction. For example, light that we see or heat that is generated in our surrounding. These two are nothing but a evidence of chemical reaction, or you can say example of chemical reaction. Similarly, temperature change is also an example of chemical reaction. Next example is formation of a gas. So when we see a vapor that is coming from a boiling water, or when we see a smoke coming out of incense sticks that we use in our home sometimes for a good odor. So those are also a type of chemical reaction happening there, and due to that, the formation of gas occur. Then the color change that we see, that is also an example of chemical reactions. And this color change here, the picture that you are seeing is a picture of rust formation. So whenever there is a rust, then you will see color change at that place, and that is due to chemical reaction that is occurring. Last example is formation of precipitate. Precipitate is nothing but a few solid particles formed due to the reaction of two aqueous solution, and when we mix two aqueous solution, these solid precipitate inside the beaker. Okay, so far we learned about what is chemical reaction and different symbols that we use to write a chemical reaction. Also we learned about few parts of chemical reaction like reactants and product and how they are written. Okay, now we will talk about the word equations. So word equations are statements that indicate the reactants and product in a chemical reaction. And these equations are written like the example that is given here. In this equation, iron, that is a solid in a state, and chlorine, that is gaseous, react together and they are making iron 3 chloride. Okay, so iron 3 chloride means here the oxidation state of iron is 3, so iron 3 chloride. Okay, you can also read this as solid iron and chlorine gas react to produce solid iron 3 chloride. Okay, so if for iron there are two oxidation state, one is +2 and +3. So here the iron is in +3 state, so that's why it is written as iron 3 chloride. Okay, now we will talk about how we can write word equations into a skeleton equations, because most of the time we use a skeleton equation, not word equation. So skeleton equations are written by using symbols. So when when you study about periodic table, you may have seen symbols in the periodic table for each element. So we use symbols to write equation. For example, in word equation, it is written as iron solid and chlorine gas is making iron 3 chloride, which is also solid in a state. And similarly, you can write a skeleton equation using symbol for iron as Fe, and then symbol for chlorine as Cl2, and symbol for iron 3 chloride as FeCl2, which is in solid state. Okay, so we will write the state of each element also, and compound also. Here FeCl2, FeCl3 is solid in state. Okay, although this equation is not balanced yet by the coefficient, we will talk about that in the next slide. What is coefficient? So let's talk about coefficient by this example of sodium plus iron oxide, and that is giving us sodium oxide and a solid iron. So the numbers that you see behind sodium and sodium oxide and the iron here, these are called as coefficient. So coefficients are number that is preceding the chemical formula, and these coefficients are used to balance the reaction. So why we need to balance the reaction? Because whatever amount of reactant we gave in the reaction, we must get the same amount of product. Okay, that's why we balance the reaction. And the a smaller number that you see with the iron in this iron oxide Fe2O3, so this 2 and this 3, they are called as subscript. Now, how you will read the above reaction that is occurring? So you can read this as 6 atoms of solid sodium plus 1 formula unit of solid iron oxide. Here the oxidation state is 3. So iron oxide yields 3 formula unit of solid sodium oxide and 2 atoms of solid iron. Okay, in the form of moles, you can say 6 moles of sodium plus 1 mole of iron oxide yield 3 moles of solid sodium oxide plus 2 moles of solid iron. So why we are writing this in moles? Because we generally talk about the form of moles, not in the form of grams or in the term of any other thing like grams or pounds, like this. We only talk about the term like particles or group of particles, that is moles. When I told you about balancing an equation, I told you that whatever amount of reactant you are giving in a reaction, you must get the same amount of product. And in another word, we call this as conservation of mass. Okay, so what it is? It is in a chemical reactions, atoms are neither created nor destroyed. That means the mass is conserved here. Okay, so whatever amount of mass you are giving, you are getting the same amount of product. For example, if you are putting hydrogen and gas to react to form water, whatever amount of hydrogen and oxygen in the reaction, you must get the same amount of water. To do that, what we will do, we will balance this equation. So here what is happening in the equation, in this equation, is that the one oxygen atom is went missing here. Okay, so you can see that here only we have one oxygen, and in the reactant we have two oxygens. So but according to conservation of mass, uh, either amount should be same, the product and the reactant. So what we will do, we will balance it. So we will put a coefficient of 2 for hydrogen, and coefficient 1 for oxygen, and then coefficient 2 for hydrogen and oxygen here, that is H2O, water. Okay, now if you check for the reactant, you will see we have how many amount of hydrogen here. So multiply this a smaller 2 with the bigger 2, so it's 4. Number of hydrogen is 4 here, 4 atoms of hydrogen here, plus what amount of oxygen? 2 times 1, that is 2. Now check the total number of product here, total number of atoms in product. So again, we will multiply uh, H2 with 2. So 2 times 2, 4, and plus 2 oxygen, 2. Now you can see that the number of atoms in reactant and number of atoms in product both are same. So now we can see this is a balanced equation, and here the law of conservation of mass is followed. Also we have to remember that not all properties are conserved in chemical reaction. So here is the list of properties that are conserved and the properties that are not conserved. Okay, so mass, types of atom, and numbers of each atom, that should be conserved. That means whatever the mass or types of atom or number of atom is in reactant, you must get the same in the product. The color and the physical state and the number of moles, these things are not conserved. Okay, so you will get a different amount of uh, moles in the product or in the reactant, and also the color will change in the product. You may have seen different reactions where the color are changed. Then also the physical state are also changed. Okay, so for example, if the reactant is solid, then it is not necessary that our product is also solid. Okay, similarly, if reactant is gas, you can get a product that is liquid. Okay, so these things are not conserved in a react. Okay, so that's all for the basics of chemical reaction. So in this video we learned about what is chemical reaction, what are the different terms that we are using in chemical reaction, and then what is the balancing of a reaction, also the law of conservation of mass. Thank you.